Welcome to the Crazy Hat Chemist. So today we're doing the second video in thermochemistry. So let's get moving. Bam! So today we're going to be talking about units of energy, that's NRG, and specific heat capacity, and understanding what is specific heat capacity. So the heat energy is expressed as the joule, not like the family jewels or the jewels that you wear on your, ring or something like that. The joule is not a SI unit, but it is derived from a set of them. And here it is. So 1 joule is equal to kilograms times meters squared divided by seconds squared. That is a very important set of units to memorize because we're going to be using that multiple times. Okay? All right. The quantity of heat, either lost or gained, required to change the temperature of 1 gram of any substance, whatever that substance is, by 1 degree Celsius is called the specific heat capacity. It is denoted as a capital C with a lowercase p, so that's CP. Sometimes it's just shortened as a upper capital C, and that works out fine too. Okay? So some notes on this, and that is 1,000 calories is equal to 1 kilocalorie, which is equal to 1 kcal. And that's equal to 1 food calories. Notice it's a capital C calorie. So if you look in the back of the box of your cereal, you're looking up calories with a capital C. Okay? 1 lowercase c calorie is equal to 4.184 joules. And that's a very important number, as we're going to find out here in just a second here. That is the conversion. Okay, here are some specific heat capacities for some specific items here. And notice the first one is water. Okay, so water is 4.184 joules per gram degree Celsius. Notice that that is the same number as the conversion between joules and calories. Not so strange. Now, if you look at the rest of these are far below that of water. Water has a tremendously high specific heat capacity. Okay, and we're going to find out what that number means here in just a second. Okay, so here are some pots and pans that are inside my kitchen, and they are made by a layer of metals. Okay, so here is the layering of metals. On the inside of my pots and pans is an 1810 stainless steel. That 1810 stainless steel is relatively impervious to a variety of different things that we cook with. We cook sometimes with tomatoes, which are acidic, and so we don't want it to pit that metal. Okay, so it's relatively strong. It's also very easy to clean. The next layer is a thin layer of aluminum. And then there's a thick layer of copper in between. Okay, then a thin layer of aluminum and another layer of 1810 stainless steel on the outside, or sometimes aluminum on the outside. Okay, and again, that's so that it's really nice and easy to clean. There are some pots and pans that are made solely of just copper, and those ones are super expensive. So I want you to look at the specific heat capacities of that table that I have right there, with the top being water, the bottom being gold. Okay, that's very important here. And I've highlighted with colors where my specific heat capacity is for certain elements. That is, aluminum is 0.902. Okay, iron, which is not used in my pots and pans, and then there's copper, 0.385. Okay, there's a cast iron pot that I have at my house too, and I've delineated its specific heat at 0.473 joules per gram degree Celsius. So why are certain pots and pans made of certain different types of metals? Okay, and here's why. So the higher the specific heat capacity, the longer it takes to heat or cool the object. So if you look at water at the top of this here, water has a specific heat capacity of 4.184. This is why it takes so long to heat up water and make it boil. It's also why if you live near a beach, your temperature is relatively constant, because that is a giant amount of energy in that ocean, sea, or body of water, whatever it is. Counter to that is the lower the specific heat capacity, the shorter it takes to heat or cool that object. So ideally, if I could afford it, my pots and pans would be made out of gold. That is a specific heat of 0.129 joules per gram degree Celsius. That will allow that flame or that heating element from my stove to heat up that gold pan very quickly and then transfer that heat to whatever I'm cooking in there, whether it's frying an egg or cooking fish or some tomatoes or whatever. Right? If I have a pan made of aluminum, it takes a longer time to heat up that pan and a longer time to dissipate that heat to that food item. So that's why the most expensive pots and pans are made out of copper, because it is the most readily available metal with the lowest specific heat, making them relatively cost efficient. Right? Silver pots and pans don't work. That's too expensive. Gold won't work either. In fact, it's too soft of a metal anyways. Okay, so hopefully that makes you understand why specific heat capacity is so important. Make sure you memorize that definition in the yellow. Okay, there's the molar heat capacity of water, and this is the specific heat capacity of water, and these values come from the CRC Handbook of Chemistry and Physics. That's a big, gigantic, thick book that has all the constants that we ever need, including all the calculus, integrations, and derivations of equations. This is James Joule, and he's the guy that we have the joule, the heat energy term that's expressed after from all his research. Okay, I hope you had a fantastic time watching that. I have another hat for you here today, and I am the Mad Hatter. Okay, give me a thumbs up if you like that video, and please subscribe to my YouTube channel, and I will see you next time for some more awesome chemistry videos.